Right, okay, so I'm gonna talk about merge sort and I'm gonna show you how to demonstrate the process of sorting using merge sort. Now merge sort is one of um, the kings or queens of sorting. It's phenomenally fast with large data sets. Okay, so whereas we looked at bubble sort and insertion sort, and we saw that they're not too complicated. Okay, the process is simple enough, particularly with the bubble sort where you just keep comparing pairs until you didn't have to do a comparison, and then you say, oh, well, it's sorted then. And then insertion sort that just says, let's just feed each number back and see where it fits in this left-hand list, which we're basically maintaining the order of, and we just keep going until we get to the end and we say, right, well, they've all been placed now, so it must be sorted. So they're actually quite simple, but they have a real big issue. They're affected, their speed of operation is affected by how the data is before it's sorted. So they work really well, bubble and insertion sort, when we have got data that's nearly or partially sorted. They don't have to do much work, so they're actually quite quick. They also don't like large data sets. They're what we call, and we talk about this at A level, they're what we call polymetrics, so they're squared. They're what we call in big O terms n squared. So they've got two loops, and you can see that from bubble sort. It's got a loop that's doing a scan along, and it's got a loop that's saying keep doing this scan along until we don't swap. And with insertion sort, you have to visit every single item, and then you have to look back. So you've got two loops, one inside another. So they suffer. Once you get a lot of data items, the time they take to do their sorting goes up squared. Okay, so if I've got 4 items, that might take proportionally 16 times to sort because it's 4 squared. But if I had one more data item, that takes 25 times, and that obviously gets worse. So you get that a nice curve like that, an x squared curve. Okay, so as we add data items, their performance really becomes rubbish. So what we need is we need more sophisticated algorithms. And merge sort is one of those algorithms. It actually doesn't sort anything. Okay, what merge sort does is it's a partition sorting technique, and it makes use of the same thing that insertion sort did. So insertion sort, we said that if you've got a list with one item in it, then that must automatically be sorted. Okay, so okay, it sounds a bit weird, but it's true. If you've just got one item in a list and you say, is that list sorted? And you say, well, obviously it is, there's only one thing in there. So what merge sort does is does that to the extreme. So it takes a list of numbers and it says, right, okay, these are unsorted. Why don't we just, instead of having one list, let's say we have 10 numbers in our list to sort. What merge sort says, it says, right, instead of having one list with 10 numbers in it, why don't we have 10 lists with one number in? So that we can say that the problem is not how do you sort numbers, but how do you join together 10 lists that are sorted? And that's what merge sort does. So it has this two-step process of splitting the list up. So it consists of a number of lists with one item, and then all we do is we take pairs of sorted lists and we merge them together. And you'll see that when I do the demonstration. So it's really one of the nice things about programming and algorithms is that sometimes you can come at a problem and think, well, I just don't think literally about it. Let's do some weirdness here. And that's what merge sort does. It's what makes it a beautiful algorithm. Okay. And like I say, we study this in detail at A level because it is quite interesting, the process that goes on to do that. It has got one downside, and the downside is it uses memory. Okay, so with bubble sort and insertion sort, we call those in place sorting because we just move things around inside our list. Merge sort effectively has to use twice as much memory because we build new lists. we're not going to worry about the implications of that for what we're doing, but it is something that you need to be aware of. It's one of the downsides to it. Okay, so sometimes when you're in tight memory restrictions, you can't use these fancy algorithms like merge sort. There is another algorithm called quicksort, which is, as its name suggests, quick. It has some of the benefits of memory footprint that bubble and insertion sort do, but also uses the clever strategy of a single item on its own is sorted, but works in a different way. And again, we look at that one at A level as well. Okay, so that's an overview of it. So it has these two broad phases. So the first bit is to split a list up, and this is something we can demonstrate and nicely demonstrate to the examiner. Once we split that list up into all these separate little lists, and I'll show you how to do that, what we then do is we then merge them back together. Okay. What's nice about merge sort is that you can actually use it with external storage. If you've got files that are sorted and you want to merge files, you can use the same process to do that. It's actually quite a nice little programming exercise to do that. And in fact, I'm going to get my year 12 to do it now. Now I've just thought of that. Okay, so that's what it's about. Let's have a look how it works. So let me scroll my page. I'll do it vertically then. Right, so let's say we have got a list of numbers. Now, and I'm going to show you a different way of writing a list. Okay, and this particularly makes sense when we're doing merge sort. Right, I'm gonna do a set of numbers. So they don't have to be in order, which is nice because I can't think of any numbers in order. 17, 12, 9, 3, 2, need a couple more, 8 and 15. Right, so I've got a list of numbers. Let me scroll that up the page now. Whiteboard is really weird. It doesn't let you move things off page. Right, I'm going to mark the list. Now I could put boxes around all this and make it look like an array, but what I'm going to do is I'm going to use square brackets to mark the start and end of the list. Okay. Now, the other thing you might want to do to make this tidy is to use commas to separate. So we can see that it isn't 815, it's 8 under 15. Right, so we do the first phase. The first phase is the split. So what we do is we don't split down to ones, we do it in steps. So we divide this list into two. Okay, so we just say, right, okay, so let's divide it into two. So we end up with two lists. We're not moving anything. Weird. We're not moving anything. We are just splitting the list. So we're doing the split. So we end up with one list. Now you can see why I'm doing the brackets. And then I've got another list. So I split, and I just keep halving the list, splitting it into two each time. And you can do this independent. I can ignore the right hand list for now and just concentrate on this one. So I keep splitting until, so now I'm going to split this again into two lists. So I'm just going to make two lists. And I'm going to put, in this list, I'm going to put a 4 and a 17. In this list, I'm going to put 12 and 9. So there's no complicated maths going on. There's no decision making going on. All I'm doing is splitting. So I'm just going to finish this half off. So I've got to split these again because I'm not down to singles. So eventually I get down to a list with 4 in it, which is sorted. A list with 17 in it, which is sorted because it's on its own. A list with 12. And a list with 9. Okay, right, let's concentrate on the right hand side now and get that split down. So this splits again into two new lists, and it's this making the new list that is the thing that causes the memory to be used. I won't go into the technicals of it, but we will look at that at A level. Okay, so I've got to keep going because I only stop once I get down to singles. So I'm going to take this and split it into two lists. So I've got a 3 on its own, which is sorted, a 2 on its own, which is sorted, an 8 on its own, which is sorted, and a 15. So that is the end of the split phase. Okay, so at this point, I have got, in this case, I have got 8 sorted lists. So without doing any work other than just splitting up, I've managed to actually get a set of numbers that are sorted. Believe that or not believe that, it's up to you. Okay, but I'm saying that is that premise of an item on its own in a list must be sorted. So the next phase is the merge. So now I say, right, okay then, what I'm going to do is if I've got lists that are sorted, all I've got to do is read the data from a pair of lists and I can pull them together and just put them in the correct order. So let's have a look at how this process works. So I just take a pair of items. So I've got this list and I'm going to use a little dot to mark where I am. And you'll see it doesn't make sense to start with, but it will do later on. So I'm going to put a marker at the start of each list. Now what I'm going to do is I'm going to look at the 2 numbers that are at the markers and I'm going to say which one is the smallest because I'm going in ascending order. Okay, so I'm going to make a list that's going to hold 2 items because I'm looking at a pair here. And I'm going to say, right, which one of those is smaller? And I can see that 4 is smaller. So what I do is I write down the 4. I then attempt to move the marker to the next item in the list, but there isn't anything. So I stop. Nothing left. And I say, right, okay, then whatever's in the other list, write that down in the new one. So I'm making a new list up here. I then just work on more pairs. So I'm doing it, it's all in levels this. So I'm going to work on the next pair of lists. And I'm going to do the same thing. Make space that will contain 2 items. Yeah, it's very weird how I drew that. And I look at what I've got at the 2 markers. And I go, right, okay, the smallest of those 2 is 9. So I'm not actually sorting, I'm just looking at pairs. So I then go, right, okay, move on to the next. Oh, that's it, there's no more items. So just take the contents of the other list and write them down. And I keep doing this. So I now go, make space for another 2. Put me little markers in. So I'm not actually sorting, I'm merging. It's a slightly different process. So I'm going to say, right, of these 2, 2 is smaller. So write that down. Try and move to the next item. Oh, no, no more in there. So just write down what's in the other list. And then my final pairing on this phase of the merge. 2 spaces for the 2 items that are in this list. Put my little markers in. And go, right, okay. Looking at the items at the 2 markers. 8 is smaller, so let's write that down. Try and move to the next item, but that's the end of the list. So stop. Write down whatever's in the other list. So at this phase, we've now got 4 ordered lists. So we had 8. I can't spell ordered. But now we've got 4. Right, so someone's asked what if there's non-number values. I'll do that on a second example and I'll show you. It's no different, don't worry. Okay, so now I'm at this phase where I've now got 4 lists and each one is ordered. You can see I've got a 4 followed by 17, I've got a 9 followed by 12, a 2 followed by 3, and an 8 followed by 15. They're all in ascending order. So let's go through the merge process again. So we're going to take a pair. This time there are 4 items in total, so we need a list that can hold 4 things. And we're going to put a marker at the start of each one. And we're going to say, right, okay, look at the start, at the marker for each list, which is the smaller. Well, we can see it's 4. So we write down the 4. Then we move the marker along, and you say, this time you see it makes sense. And we just say, right, okay, at the markers, which is the smallest? And we say, well, 17 and 9. Well, it's obviously 9. So we write down the 9 and move the marker. Again, we say, right, okay, what's the smallest thing at the marker? Well, it's 12. Oops, I caught my keyboard then. Let me scroll up a little bit. It's 12. So let's move that marker along. Oh, we're at the end of the list. So just write down whatever's left in the other one. So you can see at the end of that process, we've ended up with a list with 4 items, 4, 9, 12, and they're in order. Even though I haven't done any complicated sorting. It's magic, this algorithm. Let's have a look at the other pair that's left. Space for 4 items, because that's what's contained in those 2. Right, so put my markers in. Look at the items at the 2 markers. Which is the smallest? Well, it's 2. So I write my 2 down. And then I move my marker along. And I say, right, okay, again. And I just go through this little process. What's the smallest item at the 2 markers? Well, this time it's 3. So I attempt to move along. And I say, well, actually, I've exhausted that list. There's nothing else left in there. And that means that everything remaining in the other list is bigger. So I can just say, well, dump it. I don't have to do any more testing now. Don't even have to compare anything. I just say, right, write down the 8. Move on. Write down the 15. So it was a little less work for me. So one of the beauties of merge sort is that it reduces the amount of work, the amount of movement you do, the amount of comparisons. Because comparisons take time, and so does movement. So now, after that, I have got 2 ordered lists. Or sorted lists. I prefer ordered, because we haven't actually been doing any sorting. So, my final stage is to take the remaining pair of lists. And you can see they're in order: 4, 9, 12, 17, 2, 3, 8, 15. Magic. Make a final list up that can hold 8 items, because that's how many I've got in total in my 2 lists. Put my little markers at the start. And I would advise you doing these little markers, because it shows the examiner what you're doing. Okay, so I go 4 and 2, 2 smaller. Let's write that one down. Move that marker along. So I'm doing the little arrow to show that I'm doing that. At the head of each marker, I've got 3 and 4, so 3 smaller. Move that marker along. 8 and 4, 4 is smaller. Move this marker along. So you see how it just automatically, it's a nice little process. Nothing complicated. We're just adding 1 to an index each time to move along. Right, so we've got 9 and 8. 8 is smaller. So move that marker along. So you can see that we've nearly finished processing the right-hand list, but we don't look at that yet. So now we go like, okay, 15 and 9. 9 is smaller. Move that marker along. 12 and 15. 12 is smaller. Move that marker along. 17 and 15. 15 is smaller. Move that marker along, but we've finished. We've got to the end of the list. So whatever's left here, just write them all down. So 17 goes down. Try to move to the next. Nothing. There we've got 1 ordered list. To me, merge sort is one of the beautiful things about algorithms. It solves the problem of how do you sort numbers by taking it from a completely different direction, from looking at it from a different point of view. Okay, right, let's do one more. And just, double check that you haven't screwed anything up. 2, 3, 4, 8, 9, 12, 15, 17. Right, let's do one with an odd number. So let's try to do, let's do 9 items. So new list. So I've got to think of 9 new numbers. So let's have a go at 7. I'll put it straight into it. I've got to count 9 as well. 7, 14, 3, 2, 12, 15, 18, 9. I've got 1, 2, 3, 4, 5, 6, 7, 8. One more, and let's have 0. Just for lols. Okay, so now we've got 9. So that's odd. So that's not going to divide evenly. But let's just go through the process. Let's split it into 2. So I need 2 lists. So I've got 9. So it's going to have to be a 4 and a 5. So I'm going to do 5 in the first one. Let's just do 5 in the first one. So I'm splitting this in two as best I can. Not changing the order of anything. I'm just doing the split phase. And then I need another list that can hold 4 items. So 15, 18, 9, and 0. Okay, so that was one layer of splitting. We just keep going, and we only stop when we get down to singles. Okay, so again, I've got an odd number. So I go, right, okay, I'm going to make a list that can hold 3 and a list that can hold 2 then. I can't do anything better than that. So don't change the order. No need, and we're not doing that. We're just subdividing the list. This one's got an even number, so that nicely splits into 2 2s. And then a final one, 9, 10. So don't change the order of the numbers. Don't make that mistake. We're not looking at the numbers. We are neutral. We're agnostic. Merge sort is a beautiful sort because one of the things, he doesn't care how jumbled up the numbers are. It's a fixed cost based on how many items there are. Okay, so it's actually quite nice because you can rely on that and you can calculate how long it's going to take to do its sort. Right, we carry on. We haven't got down to singles yet. We've got a 3, so that's going to give us a 1 and a 2. So I'm going to do 7 on its own. And again, this is up to me. It's arbitrary, as long as I split. 14 and 3. So I've ended up with a pair there. These are going to split into 2 singles. So 2 and 12. This one's going to split into 2 singles. 15 and 18. This one, final pair, is going to split into 2 singles, a 9 and a 10. Right. Normally we'd be finished, but actually we've got a pair there, so we're going to have to do another split. So we're going to split this one again, but just to keep this nice and tidy, after I've done that, I'm going to write the other ones down again, so I've got a nice row. So I split this pair into singles. Okay, so this is what I finally end up with. A 7 on its own, a 14 on its own, a 3 on its own, a 12 on its own, a 15 on its own, an 18 on its own, I don't know how I'm doing this, writing different things down and saying different numbers, a 9 on its own, and a 10 on its own. I must be a genius. Right, so we have now got 9 ordered lists. So we're going to now start. I keep catching my keyboard. We're now going to start. We're ready to start the merge phase. And again, we take pairs. So we look at a first pair and we go, okay, let's make space for 2 items because there are 2 items in these 2 lists. Put my markers in and go, right, 7 is smaller than 14, so we'll have that first. Oh, no, nothing else in the list. So I write down the 14. Take the next pair. Need space for 2. Only do pairs. Put the markers in. So 3 and 2. 2 is smaller. Okay, 2 is smaller, so that gets written down first. We move on, end of list, write down the 3. Take the next pair. So I need space for 2 items because there's only 2 items in total in these 2 pairs. Put my markers in. Get me 12 first. Try to move on. There's no more items. Write down the 15. Okay, next pair. So I'm not deviating from the algorithm at all. Yes, there was an odd number, which screwed the split up. Right, so 18 and 9. 9 is smaller. Move that on. Oh, end of list. Write down the 18. And then we've got a single on its own. Well, we haven't got another pair, so let's just write down the single. So we can't do anything with that as of yet. So now we've got 1, 2, 3, 4, 5 ordered lists. So the process is the same. Okay, I'm just going to move my head. I'll do it there. Right, I'll just go again now. So I'll go working through pairs again. And just making sure that I don't try and be clever and try and merge 3 sets together. Don't do that. Just do pairs. So we're on the next phase. This is what the exam board will want to see. So I'm going, right, I've got 2 lists. There are 4 items in total. So make space for 4 items. Put my little markers in. Right, the smallest is 2. So write down 2, move the marker in that list. 3 and 7, 3 is smaller. Move the marker in that list. Oh, end of list. So just write down everything that's left in the other one. So 7, 14. Because we know they're in order, we know that if 3 was smaller than 7, then everything else is going to be bigger than the 3. That's why we can just write the stuff down. And we get a real good benefit there. There's a speed up because we stop comparing. Okay, next pair. 2 lists, 4 items. So I'm going to make space for 4 items. Put my little markers in. Right, 9 and 12. 9 is smaller. Move that marker along. 12 and 18. 12 is smaller. Move that marker along. 15 and 18. 15 is smaller. Move that marker along. Oh, end of list. Just dump the contents of the other one. So 18 goes down. We were at the end practically anyway. And then we got little squatty 10 on his own. Let's just write it down again. We can't do anything with it yet. You'll see what happens. So we now got 3 ordered lists. So we're getting there. We're just going to keep going. Right. So I've got 2 pairs here. I've got 8 items in total. So I need space for 8 items. Right. Put my little markers in. 2 and 9. 2 is smaller. Sound like a bingo caller there then. 2 and 9, 29. Move my marker on in the 2 list. Right. So I haven't updated the other one because I haven't used that number yet. So 3 and 9. So 3 smaller. Move my marker along. 7 and 9. 7 is smaller. And can you see that the decision process are actually quick? It's a quick process. I'm not having to think what to do. I'm just saying, right, that's smaller, write it down. Move that along. Right, 14 and 9. 9 is smaller. Write down. Move along in that list. 12 and 14. 12 is smaller. Move it along in that list. 14 and 15. 14 is smaller. Move it along. Oh, end of list. Dump the contents of the other list. So 15 goes down. 18 goes down. 10 on its own, little old sad 10. Just keep it down. So we've now got to a stage where we've got 2 ordered lists. So we've got 1 more merge to do. And then hopefully we're done. So I'm just going to scroll that up a little bit. If it lets me. Right, so I've got 2 lists. I need to be able to store 9 items. So I need a list capable of storing 9 items. So I'm going to draw a big list. I'm going to put my marker in both lists, even though there's only one thing in there. Right, so I go 2 and 10, 2 smaller. Move along in this list. 3 and 10, 3 smaller. Move along in this list. 7 and 10, 7 smaller. Move along in this list. 9 and 10, 9 is smaller. Move along in this list. 12 and 10, 10 is smaller. Now this is the super knock-on benefit. Move along in this list. Oh, we're at the end of the list. Dump the entire content. No more comparing. Just say, right, okay, dump 12, 14, 15, 18. 1 ordered list. Now I'm going to check. Can't write list today. Right, so we've got 2, 3, 7, 9, 10, 12, 14, 15, 18. And the last time I looked, that was an example of ascending integer numbers. So that is merge sort. So the key thing is having a nice, clear, logical way of presenting this so that you can show your working, you show the split phase down to the singles, you show the merge phase with the moving the little pointers inside each list so that you keep your comparisons clear. And then your final sorted list. Well, right, someone just asked, how do you know when numbers are ascending? Well, you do this, don't you? You would say, if this list was called list, so you'd just say if list of position 6 is less than list in position 10, you just have something like that. And then you say, right, well, if that's true, then the item here is smaller. Okay, so if we had two lists, let's just write it as an example of merge sort. Let's say we had a list called A and a list called B. So you could say AI, is that less than BJ? We need to be different pointers. And then we would say, right, okay, if that's true, then let's say we were creating a new list, and this is your problem. We've got multiple lists on the go. So we would say CK, so the position, so I, J, and K are our indexes, so they're the little pointers. Okay, so we have a pointer in here, but we don't write it down because we just got a blank. So we'd say CK equals AI, and then we'd say I plus plus, so I move along the I, or we'd say else CK equals BJ. So we're saying the item in list B is the smaller one, and then we then move the J along. So you'd say something like J plus plus, and then we need to set up so we're putting something in the right list, and you just have this, and this would be your merge loop, and you just keep doing that. I don't want to get into the actual algorithm because it's a little bit different to that, but that's in essence what I've just done. Okay, so we're saying, right, which one is the smaller? Okay, copy that one into the new list and move that pointer along. If the other one was the smaller, copy that into the new list and move that pointer along. Okay, so in essence, that is merge sort. Right, so I'm just going to stop that recording because I want that to be like a little encapsulated thing.